So today we're going to be talking about a couple different ways that we can map the surface of the Earth. So first, it's satellite imagery. We can take pictures from space or from up in the sky to create topographic maps, geologic maps. We can use the images to monitor water supplies, track hurricanes, wildfires, migration patterns, lots of things. There are just lots of different ways we can use pictures from the sky when you need pictures of Earth. Landsat, and recently Landsat 2 is a project by NASA and the U.S. Geological Survey, another government organization that collects pictures from space. And we can use that and we continue to do that both from Landsat, Landsat 2, which was launched recently. There's an Earth Observatory. There are lots of different people and groups that are working to just regularly take pictures of Earth from space to get a much wider view. The synthetic aperture radar, or SAR, uses radar technology to map the surface of planets. We can do that with Earth. We've also done that with Venus. We can see we haven't gone to really truly study very well the surface of Venus, but we know what a map of it looks like using this radar technology. So here is a Landsat image of some volcanoes. These aren't always taken in true color. This isn't necessarily they are blue volcanoes, but we can use colors as a way to show differences and show specific things that are happening. This is another false color. There's nothing actually pink and purple, but this is a map of Dallas taken using satellite imagery where the colors show population density. We can also use it to track how water supplies change. This is the Elephant Butte Reservoir in 1994, and you can see there was a dam built there at the top of the Rio Grande, and now recently in 2013 it is a little emptier than it was in 1994. So we can track water usage or land usage using these satellite images. There are more pictures here. We can see the smoke from fires as they range. The fire here is not very big, but we can see how the smoke is moving and how much area it's covering. Weather, tracking typhoons, hurricanes, any kind of storm, really, that's all taken with satellite images. And then we can use satellite images to make topographic, or some people say topographic maps. These are maps that show the features of the surface using contour lines to represent different elevations. So it is a flat map that is able to show you the elevation or the height of different areas. It's useful for finding resources, engineering, planning cities, determining the best way to hike a mountain, all sorts of different things. There are a couple rules that we follow when making topographic maps. One, the closer together your lines are, the steeper your slope. So in a little bit, we'll look at some examples of topographic maps. But when you've got lines that are really close together, that means the elevation is changing rapidly. So it is a very steep area. If your lines are more spread out, then the elevation is changing slowly, so it is not super steep. The different contour lines represent areas of the same elevation. If contour lines follow a stream, a river, or a creek, they will bend upstream, or they will form a V or a U shape that points to where the stream is coming from. The V, the tip of the V, or the base of the U will point to the top of the stream, or where the river is coming from. Rings of consecutively smaller contour lines, if you get circles inside of circles inside of circles, that's going to be a mountain or a hill. The elevation is increasing on all sides before you get to the top. The highest possible elevation of the hill is just below what the next contour line would be. So if the top circle on your hill says 120 and the next possible contour line is 130, well, that means nowhere on the hill does it reach 130. Otherwise, there would be a line that says 130. So you've got a 120 line. There's no 130 line. That means the tallest possible height of that hill is 129. it hasn't gotten tall enough to need the next line. So the highest possible elevation is just below what the next line would be. And again, we're going to look at an example of this in a second. Area where the land dips, where there's a hole in the ground, that is called a depression, and that is shown using little tick marks called hatchers or hatch marks. We'll see there are sometimes just little tiny lines around contour lines to show these depressions. And then similar to a hill, this is like an inverted hill, an upside down hill. So the first hatchered line will have the same elevation as the previous contour line, and then like a hill, the lowest possible point is just above what the next contour line would be. So if I've got a hole in the ground and I have a contour line that says 20, but there's no line that says 10, well, that means this hill or this hole in the ground, the deepest it can go would be 11 because it doesn't reach 10, otherwise there would be a line for 10, but there is a line for 20. So here is an example of a topographic map or topographic map. We can look at some different features here. You can see places where the lines are close together. This is going to be a very steep area. Places where the lines are more spread out, maybe on this side, that is going to be not super steep. The elevation isn't changing quickly. Here, where it even says Katy Hill, I've got circles inside of circles. So this is a hill. It is places where things are going up. That's a great example of where the land is elevated. The thick lines that have numbers we use as special markers. Those are contour lines that can tell us exactly what the value is. Not every line will have the value listed, but I can see this one here is 1,000. This one here is 900. And I can see that there are 1, 2, 3, 4 gaps in between. Let me make sure I counted that right. 1, 2, 3, 4. 1, 2, 3, 4. There are 5 gaps in between. That makes more sense to me. There are 5 gaps in between. This one is 900. This one is 1,000. So each gap in between would be 20. So the next contour line would have a value of 920, then 940, 960, 980, and then 1,000. We're going to do lots of practice with this to see how can I read these contour maps and what does this really tell me about the surface of the earth, and how can I look at this and know where the best place to hike is.